We're recording, here we go. So lecture number 25, graphs of signs. Now, we are going to be using the unit circle quite a bit today. So if you'd like to take out your unit circle, that'd be fantastic. But you might want to have notes out as we look at the graph. Now, what we're doing is, this is just like back in Algebra 1 or Algebra 2 when we talked about a parent function. We talked about like, what's the characteristics of x squared, what's the characteristics of absolute value, the domain, the range, the end behavior, all those different things.
Would you like my conference set?
I would like for you to be taking notes and paying attention.
I cannot take notes because I don't have a notebook as of now.
Paper?
There's blank paper back there.
Is this on Schoology? As of now? Or, like, I'm about to take notes.
No, it's not on Schoology.
Oh.
I did not record or I did not save my notes. Today's notes will be saved.
They will be, okay.
Maybe, if I'm in a good mood.
Okay.
And people are complaining about Jolly Ranchers, things like that. Not that I'm looking at anyone in particular. Okay, so what we're going to do is we're going to introduce to you what the sign graph looks like, and then we're going to talk about how it corresponds to the unit circle, and then how we can move it, translate it up or down, left or right, how we can stretch the wave, how we can compress it, all of those different types of things. And by the end of the day, we're going to be able to graph the sign function with the change of amplitude, with the change of length of its period. We're not going to do horizontal movements yet today. The moving left or right, that gets a little bit more complicated. So I'm going to save that for next week. We're going to try to do this one thing. Then hopefully we'll give you some time in the class to finish some homework that's due. So, and by the way, don't forget today is the last day of the quarter. I've already posted grades. Grades are not really finalized today. They're not transcripted until semester. So your grade is going to continue to climb, or fall, or stay the same, or whatever. Yes, ma'am. What's
It's
your
a
question?
sign thing like that.
Wow. Why are you jumping ahead of me? Just be patient. I'm going to get there. Okay? I'm glad you think you know the answer, and that's awesome. Awesome. Let's be more specific. So if you remember, back when we were Algebra 2, what's the very first thing we did when we started graphing things?
Probably.
If you remember, we started making a table. And I put in x of f of x, and then I used -2, -1, 0, 1, and 2. Well, today we're going to do something very similar, only we're not going to use -2, -1, 0, 1, and 2. We're going to use some different ones dealing with the unit circle. So the first thing is I'm going to go ahead and make a horizontal graph rather than making it vertical. And I did that just because I want to be different. Okay?
Wait, we did this last week, didn't we?
So then I'm going to have x. Actually, in this case, I'm going to use theta, because we're going to deal with the function f of x, or f of theta is going to equal the sine of theta. That's the graph we're going to be looking at. So this is going to be the function of theta. So the points I'm going to use, and the points, these are ones I'm choosing to use because when we see the graph, you'll realize why I'm choosing those functions, those points. There are 5 of them. We're going to choose 0. We're going to choose pi over 2. We're going to choose pi, 3 pi over 2, and 2 pi. Now someone, please raise your hand and tell me, why did I pick those 5 numbers? Yes, Rockman.
Because they are the top of the y, the bottom of the y, the far of the x, the other side of the x, just the points.
Okay, do you remember what we called those?
Well, the diameter or the radius.
No? Well, they're all, everything's a radius.
Yes.
Like the coordinate points, like the first points that we started with. Like
But there's a special name for
dang
that.
it. The ordinate points, something. I can't remember.
Okay, stop guessing. Any other ones? Guesses? Do you remember?
Stop guessing.
Stop
Is there
guessing. Any other guesses? What'd you say, River?
Like circumference or?
No. Starts with a Q.
Quotient.
Quadrantal. These are the quadrantal.
I would not have gone that. I'm not
These are
gonna
the
go
angles. These are the angles where the terminal side is on one of the axes. Okay, the terminal side. So the initial side is always the standard position.
Yes.
The initial side is always at positive x. So when you go to the quadrantals, they're on the axes. So these are the ones on the axes. So someone tell me, what is, from your unit circle, what is the sine of 0?
0.
What is the sine of pi over 2?
1,
What's the sine of pi?
0.
What's the sine of 3 pi over 2?
-1.
-1.
-1. What's the sine of 2 pi?
0.
0. Another thing that's unique about this is it gives me the 3 places where sine hits 0. It gives me the roots. It gives me the x-intercepts. It also, what do we know about this point here? What do I know about pi over 2? Well, that's where the sine hits its max. What about the sine of 3 pi over 2?
It's where it's at the bottom.
That's where it hits its minimum. So that's the reason why I picked those 5 points, because I have 0 its starting point, where it goes to its max, back to its starting point, its minimum, and back to its starting point. Okay?
So I was right. But
Okay, so let's go ahead and graph our parent function of the sine function. Okay. So I'm going to go ahead and just start one, and you're going to make this about 15 times a day. So just get in the habit of making it. If you have graph paper, it's going to be much easier. If you have regular paper, just draw a line. What I always do is I always start out here, pick an arbitrary point, and I pick that to be 2 pi. Then it's just a matter of cutting it in half, because I can pretty much judge where that is in half, about right there. That's going to be pi. And then I cut each half in half. So this is going to be 3 pi over 2, and this is going to be pi over 2. It's much easier than trying to make 4 equal quadrants. Set an arbitrary point, cut it in half, cut those in half. Okay. And then going up to 1 and going down to -1. And then we're going to graph our points. We start off at the origin. At pi over 2, I hit my max, back to 0. I hit my minimum, back to 0. So I have something that looks like a wave. Something like that. Now, we're only going to graph today. We're going to focus on graphing what's called one period. Because we know with the sine wave, it's a wave where it continues. It will continue going like this, hitting its max at 5 pi over 2, hitting back to 0 at 6 pi over 2, and continuing that pattern. Minimum at 7 pi over 2, back to 0 at 8 pi over 2. Every pi over 2 it's going to keep hitting. We also know it's going to go this direction. So it's going to hit its minimum at negative pi over 2, back to 0 at pi, or negative 2 pi over 2, and then maximum at negative 3 pi over 2, and so forth. Okay? So it's going to keep hitting those directions. It's going to keep, but we're just going to focus on just this one little section. We call it its first period. Just that one period. Okay? If you're taking notes, hang on a second. If you're hitting notes, you might put in here, this is the 0, this is the maximum, this is also a 0, this is your minimum, and this is also your 0. Now, I can obviously change those and move them and stretch them out and stuff, but if we can find those 5 points, I can always graph this particular sine wave. Okay? I apologize. What was your question?
what would you like name this, like the parent function of what?
Sine of x. Sine of theta.
So it would be f of x of theta, or?
I wrote f of theta and sine of theta. You could write f of x and sine of x. You could write f of b and sine of b, as long as they match. Okay? All right, now, as we look at this, if you remember back in Algebra 2, probably in Algebra 1 with your Algebra 1 teacher, after we kind of got the 5 points and we sketched it and kind of looked at it, then we listed its characteristics. So let's real quickly list what are the characteristics of this graph. Now, I've already told you one, that it cycles. It's a wave. You can put it cycles, it continues forever. It cycles, or it's a wave. However you want to talk about that. Now give me some other characteristics, some basic characteristics of this function. Yes, what's one?
The minimum is -1 and the max is 1.
So what's that called?
The range.
The range. So the range, I'm just going to put an R, is going to be -1 to 1 brackets. Because it does actually get to -1. It does actually get to 1. Okay? Kevin, what's another characteristic of this particular graph? Its domain is all reals. Or if you want to put negative to positive infinity. Okay, its domain goes on forever. There's no oopsies, there's no no-nos, there's nothing like that. Okay, what else is another characteristic? River.
Increases and decreases, I guess.
It does increase and decrease, but so it has several turning points, right? I'm not going to put that down, but you're right. It increases some points, it decreases some points. Okay? What else? Yes?
It's even. Actually, no, it's odd. My bad.
It's odd. Because it reflects around the origin, so it is an odd function. Okay, very, very good.
Wait, can you describe again what it means if it reflects around the origin?
So if I were to take this, and this continues in this direction like this, if I take it and rotate it 180 degrees, turn it upside down, it'll look exactly the same.
Oh, okay. And then like if it was even, it means it was symmetrical across the origin.
Correct.
Okay.
Correct. So this one is considered an odd function. Yes.
It passes the passes
Passes.
vertical, but doesn't pass the horizontal line.
Very good. So it passes the vertical line test, but it fails the horizontal line test. Now, so vertical line test, that tells us that it is a function. But it fails horizontal line. What does that tell us
Not a
now?
one-to-one.
It's not one-to-one. That tells us what?
Yeah, there are gonna be multiple Y's.
Say it again.
There are gonna be multiple Y's. There are gonna be multiple X.
No, the inverse.
Yeah, he's saying it without being called on. Yes, there is no inverse. However, there is. So we're gonna have to deal with that problem later on in the unit when we start talking about inverse sine, because it does fail the horizontal. Okay, but we'll talk about that when we get to, then how can I possibly have an inverse? Well, we can, and we'll discuss that, okay? What other characteristics do you have for this? Make sure I get everything off my list.
It is, oh, somebody already said this, but it's increasing.
And
Decrease.
decreasing.
Yeah, but it's positive. That's what I meant. Like it's going this way on the thing. That's what I meant.
It doesn't always have.
Okay, don't forget though, it's going both directions.
Oh, you're
It's
right.
going infinitely both directions, okay? All right, what else? Anything else? I think we got the major ones.
It's blue on a yellow line.
I'm using school colors today.
Yes.
That's accidental, I didn't mean to do that. Okay, so here's one other thing we need,
Oh.
one other thing we need to know about it is the fact that it can be translated in several different ways. We can move it up, down, left, and right. We can compress it. We can make it longer, make the wave longer. There's a whole study, we don't really do it anymore because we don't pay attention. I mean, seriously, how many of you actually listen to a radio? Not streaming something, but you actually listen to the radio in your car or at home.
I mean,
Do you listen to AM or FM?
FM. Oh, sorry.
Do you listen to AM or FM radio? Do you listen to the radio? Do you listen to AM or FM?
I don't know.
Okay, you say you listen to FM. Anybody here listen to AM radio?
like the radio they play in the morning.
I listen to
No.
No.
What'd you say?
Accent.
Okay, accent, that's digital, so doesn't count. So the old AM and FM radio in your car has these things that are called radio waves that travel through the air, and there's certain frequencies, and certain channels have certain frequencies. That's why you tune it into 610 Sports. Okay, and actually one of my former students, Carrington Harrison, is on there. You've heard of CDOT? Okay, so they travel through there. Well, the wavelengths of AM and FM can be described with sines and cosines. And because you can compress, AM waves cannot be compressed and changed, which is why, what do you get a lot on the AM dial, for those of you who listen to it? You get a lot of what? A lot of static, because they can't modulate properly. FM, when they came along, they realized, hey, we can actually modulate those waves, and we can get rid of that static. Whole big long study about that is pretty cool once you get to that level, but it's all based upon these type of waves.
See, now that like I'm thinking about it, like my parents had that, like it's like you could see the little lines and stuff. Is that what it was?
Let me see the little one.
Like you could see like the waves and stuff on like it was like a handheld almost.
Some of them do digital and show you, or even analog will show you those waves, but yeah, that's basically the concept. Okay, so we've got the characteristics, we've got the graph, we know what it looks like. Okay, so then let's look at, one more thing. Back up. It's kind of like with 5 points, I've broken this into 4, let's just call them sections, okay? So like, let's use a different color, but still stay school colored. Let's go with, okay, pink. That's not really school colored, but it is October. So we could say it breaks it into 4 little sections, right? And we could call this one, let's say, section 1, and this one could be called section, 2. This one here would be section 3, and hopefully you realize I'm being a little sarcastic because I want you to see that connection. What do you think those 4 sections relate to? Yes?
Coordinates.
Quadrants.
Quadrants.
You said it first right time. Did the right the first time. So they're quadrants. This is the first quadrant where the sign is always positive. This is the second quadrant where the sign is always positive. This is the third quadrant where the sign is negative, and the fourth quadrant where the sign is also negative, just like on our unit circle. Okay? This corresponds directly to our unit circle. In fact, to be honest with you, when I say something like, what's the cosine of pi over 2? I'm sorry, what's the sine of pi over 2? I don't think unit circle, I think sine of pi over 2. Oh, that's the maximum, it's 1. Okay? Or if we say, what's the sine of 3 pi over 2? Oh, well, in the graph, that's actually the minimum, because they correspond directly to our unit circle. Okay? Okay, so quadrant 1, 2, 3, and 4. All right, next one. I want to give you the general form of the equation. So f of x equals, and we use x this time rather than theta, a times, and then in parentheses, I'm going to have the sine of b times x minus c plus
No use.
d. And what the heck does A, B, C, and D do for us? Okay, I'll let you write those down, and then we're going to review something for you real quick. Because the A, B, C, and D will be some sort of numbers. Sometimes they're 0, but sometimes they're going to be numbers.
Mhm.
Okay?
How come the A and B are capital but the C is from and the
Try
S
to
and
make it
the C are
capital.
yeah.
The D is also capital.
Is it?
But the sign is always lowercase, just so you know. Gonna live?
I think so.
Oh, are
Beautiful.
you okay?
Now, let's review something. Do not write the, yes, Kevin?
Why is the sine b times the x
I remember
minus
the
c
tree.
in brackets, but then the x minus c
Wow,
is
that's
like in
really hard.
parentheses?
So the X minus C is going to be a little separate. We're going to have some issues
I
with
got
dealing with
it a
C,
little bit.
which is why I'm going to wait until next week to talk about the C. Today I'm going to teach you the A, B, and the D. But that's going to be a little bit of an issue we'll have to deal with.
No, I was
Next
asking
week.
why it's like in
Rock my
brackets.
too nice.
Hang on a second. Shh, 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 shh. This is a good question. You guys are missing it. Say it
I
again.
was like wondering why like the sine stuff was like in a bracket, but then that one's in parentheses.
Okay, so that's going to be, because there's going to be a coefficient in front of those parentheses. And that's the number we're going to want. Okay, so if you can wait until we get through the A, B, and D, we'll talk about that next week and how to deal with it. Is that okay? All right, so let's review. Do not write this down. Just remember this.
No.
Okay? So if you remember back when we had parabolas, we had y equals something like a x minus h squared plus k.
Yeah.
We had the vertex form of a parabola. Okay, someone raise your hand and tell me, what does the a stand for? Or what does the a tell us?
Like if it's a minimum or maximum.
Okay, it tells us because it tells us what about the parabola? Yeah, if it opens up or down, which tells us if it's a min or max.
Yeah.
So the a is going to tell us min, max, open up or down. Okay, very good. What's the h tell us? Yes.
If it would be slid left or, wait, hold on, how much is gonna be slid by?
Slid, which direction?
Horizontally.
Horizontally, left or right.
Yeah.
And if it's in with the x, it's the opposite. So if it said x minus 2,
You add 2.
it's moved to the positive side.
Mhm.
If it says x minus 2, it's moved to the positive side. If it says x plus 2, it's moved to the, it's the opposite, right? I'm trying to do your negative and your positive, and I'm getting myself confused.
I can see.
Okay, what about the k? Somebody else?
It's the
Yes.
Y, up, down.
Up or down, how far? And it does exactly what it says. If it says plus 3, it's going to move it up 3. If it says negative 5, it's going to move it. It does exactly. So remember that when it comes to this, because it's going to be very similar, although we're going to tweak the a just a little bit. Okay? So the d, that's simply going to move the function up or down. Exactly the same way as the k. If the d is 2, it's going to move it up. If it's negative 5, it's going to move it down 5. That's exactly what it says it's going to do. Okay. Now the a is the one we want to spend a little bit of time with to begin with. A is what we call the amplitude. The amplitude. So with a wave, what is the amplitude of a wave?
How high,
Not
Yeah.
compressed.
how high and low it goes.
How high and how low it goes. So the amplitude is going to tell us, okay, how far above the middle line, above the 0, and how far below. And it's always the same with the sine wave. Okay? It's not going to go up to, it's not going to go you know, up to, and then here's gonna short, it's not a sine wave. They're gonna reflect the same distance, okay? The amplitude tells us how far above and below what we call the midline. Above or below the midline. Now the midline is simply, with our original one, simply the x-axis, okay, above our 0. Okay. So let's give you an example. I'm sick of this color, I'm sorry. Let's go back to that.
Understandably.
So let's go back to something like this f of x equals the sine, let's go with 2 sine of x. 2 times the sine of x. Okay? You got that one?
Oh, should we write it down?
Yes, this is going to be an example. So in this case, the only adjustment I made from the one I drew previously was the amplitude. Okay? So let's go ahead and sketch this one out. Remember I told you I'm going to draw like 15 of these today, right? So start off with, I see some of you not writing, I would really appreciate if you would stay with us and write. So 2 pi, I'm going to cut that in half with pi. I'm going to cut that in half with 3 pi over 2. I'm going to cut that in half with pi over 2. And then we're going to have 1, 2, let's go up to 3, 1, 2, let's go down to negative 3. I know those aren't even, I apologize. That one's just a little bit high. Not going to change it. Okay, let's go back to yellow. Okay, so you remember our parent graph, right? Our parent, we had 0, and then it went to pi over 2, 1, and then it went back to 0, and then it went to 3 pi over 2, negative 1, and back to 0, right? That's my parent, correct? Give me a yes.
Yes.
Yes. What does the 2 then do? So what the 2 does is it takes my min and my max and it stretches them. So it simply stretches it by a factor of 2. So rather than going to 1, I'm now going to go to, from 0, 0, I'm going to go to pi over 2, 2. Back to 0. I'm going to go to 3 pi over 2 down to negative 2 and back to 0. And I've simply stretched it, if you will, vertically. I've pulled them up and down. And I've made this 2. And it comes from the amplitude.
So essentially, it's like a 1 there, and then you just multiply times the number that's there.
Correct.
And that's how, okay.
Correct. Essentially, that's all you're doing. Yep.
And then from 0.
So what if it was 5? I would go up to 5, come back to 0, go down to negative 5, back to 0. Okay? Kind of makes sense?
0.
So I have a challenge for you here. Let's put it in, what color should we use? Let's use pink. Okay?
Wait, so you, okay, I did this right. So, okay. So you just, so, oh, okay.
See, none of that.
Does that mean it has a
What
different
was that?
slope?
Like thinking out loud. Rockman, what'd you say?
Does that mean it has a different slope?
Yes, but that's a calculus question.
What is this? Geometry?
This is trig, yeah. Okay, now, here's the challenge question for you. Don't shout out the answer. I have like 4 or 5 of you who just like to blurt out the answer. Be quiet. Think about this. Let everyone have a shot at it. All right? Here we go. What if this was negative 2? You were going to shout out the answer, weren't you?
No, I was gonna ask that question.
Oh, you're going to ask that question.
Yeah.
Good, good. I see one hand up. Do you have the answer for me?
So rather than going up first, it goes down first?
So rather than going from 0 to maximum, it goes from 0 to minimum. Then it comes back to 0, and then it goes back to maximum.
Like, do you want us to draw this?
And then back to 0. It's up to you. I just want you to know what it looks like. It's going to be just the exact, it's just going to go down first. It's just going to reflect over the x-axis. So it flips down and this flips up. Okay. So rather than hitting 0 max, 0 min, 0, it hits 0 min, 0 max, 0.
Mm-hmm.
Okay. All right. Good with the amplitude? The amplitude can be anything. I could make it smaller and go up to 1/2. I could have it bigger, go up to 100, make it really super high. Okay, really, really stretch those. It's whatever that number is in front that tells us the amplitude of that. Yes?
If it doesn't affect it, like the,
I'll come back. Rockman?
What does a constant do? What does D do?
That's next, hang on. Okay. Don't get ahead of me. Yes?
So if it like gets bigger when it's like, I think this is obvious, so I'm not gonna ask.
Did you have a question? I didn't hear it.
Never mind.
You got it?
I think it's kind of obvious, so I'm just not.
Well, that's okay. If you think it's obvious, go ahead and say it, because it may not be obvious.
Like, so like if you double it, it'll reach, if it's 2, then it'll reach to 2, but if it's like 1/2, would it only reach to 1/2?
Correct. Because you're gonna take 1, it's like kind of what Alice said, you're gonna take 1 times whatever that number is, and that's where the maximum is gonna be. So it's very easy to find the max and min on these. Okay? All right, you got it? You got your question?
Yeah, because does it not, like, since it's negative, it does not affect the 2?
What do you mean?
Like, it doesn't affect the amplitude of?
Because I went down to -2.
Mm-hmm.
So it goes down to -2, up to +2, and back to 0. So yeah, it's still the same thing,
No.
just
because-
negative instead of.
Because when the amplitude is just 1, it wouldn't, because it's in, yeah, okay, never mind.
Okay. All right, now, one more thing. I've used this word like 3 times. Some of you have caught it, some of you haven't. So we're going to straight just direct tell you, okay? I've used the word midline. So in this case, the midline is right here, right? It's the x-axis. D moves the midline, okay? So if it says +1 here, the whole thing is going to move up. If it says -5, the whole thing is going to move down. Let's give you an example of that. Okay, do you guys need this up here? Would it help if I lift this up here?
Yeah,
Not necessarily.
we ever write it down.
Okay, so I'm gonna say that's a no. Okay, so let's come up with f of x, oh, I don't like this color. Okay, let's go back to yellow. F of x is gonna equal, and let's stick with the amplitude being something different. Okay, you're okay with that, right?
Absolutely.
Just how far above and below the midline it goes. Okay, so let's go to 3 sine of x. And then outside of those parentheses, let's put in here +1. 3 times the sine of x plus 1. Okay, so we're going to start by sketching our thing. I'll give you a second to sketch your little, this is probably what, the 4th time we've done this already? 2 pi. I know it gets old, but you know what? It's good practice. 3 pi over 2, pi over 2. I'm going to go 1, 2, 3, 4, 5. I'm going to go -1, -2. Whoops. I wish I had a stamp that I could just say, boom, here it is. So then I'm going to go ahead and in blue, I'm going to go ahead and graph the parent function. Now you don't have to do this. I'm going to do it so you can see it. Okay? So we're going to have 0, 0. Pi over 2 is 1. 0, 0. 3 pi over 2, -1, and 2 pi 0. So the parent function looks something like this. Okay? It looks a little different than last time because I made the graph a little bit different size, the scale-wise. But that's what the parent function looks like. Okay? Give me a second to finish that up.
Oh my gosh. It sucks how, like,
Did I just not cook
one
right
thing
now?
to the,
Frick.
how do you do the curves? How do you like how do you draw a curve?
This right here.
Well, I know how to draw the curve, but how do you draw a curve? Like, how do you like get it perfect, like the perfect curvature?
So first of all, this isn't perfect. It's close. Not really. It's not perfect. Second of all, thanks to your classmates, they announced yesterday that I've been doing this for 39 years.
Oh,
So I've done it once or twice.
okay.
The more you do it, the better you get at
It
it.
wasn't yesterday, it was Wednesday.
Okay, so now I've just been corrected again because apparently I have a bad memory.
Yeah.
Although my son told me that elephants never forget, so
You're an elephant?
apparently I'm as big as an elephant.
Oh, that's the same.
Who said that?
My son told me that.
That's crazy.
That's just something like, I remember everything. He's like, of course, Dad, you remember everything. Elephants never forget.
That's so mean.
And Allison's laughing at that. That goes her grade.
Your grade is over. Yeah.
Oh,
I
well.
can't.
And what was even worse, we were taking this quiz, these stupid quizzes online.
Yes.
So we do this quiz online about what your spirit animal is. My wife got, like a beautiful eagle or something.
Yes.
My sons were getting a certain dog or whatever.
Got an elephant.
You got an elephant, huh?
No.
A hippo?
Blue whale.
Oh, that's see?
I'm like, I'm retaking this quiz. I got it 3 times in a row. I'm like, I quit. I won.
There's something wrong with being a blue whale.
Okay. Except for they're big and fat. Okay, so here's the parent function, right?
Yes.
So let's go back to this. What does this function tell me about the midline? Yes.
It moves up 1.
Moves up 1. So that means this x-axis is now going to be here. So now that's my midline. That's my 0, if you will. So that means it's not going to cross through 0, 0. It's going to cross through 0, 1. Okay?
Mm-hmm.
Wait, so that's our,
That's your new.
but is it still technically 1?
It's still
Or the
1.
Y?
Correct.
Okay.
It's still 1. But it's my new midline. It's my new base. Okay? And that point there, try to make it a little better. That number right there tells me where it's at. Okay? Now the amplitude. Be careful. I've got a question.
I was just about to ask about the amplitude.
So the amplitude now is supposed to go up. Listen to my question. It goes up from the midline how many units?
3.
3. So the maximum is going to go up 3, which means it's going to be at
4.
4. So I'm going to go up 1, 2, 3. It's going to go up to 4
What?
because it's 3 above the midline.
Oh, so it doesn't have to be at the 3 for the Y, it just has to be 3 above
Above.
midline.
Correct.
That's what my question
The
was. gonna
3
be.
tells us the difference between the maximum and the midline. So then it comes back down to 0.
Wait, is it?
Where is its?
So is the 0 now out? Okay.
The 0 is now at 1. That's my midline. Now, what value, listen to my question now, what value will the minimum be at? Negative 2, because I'm at 1, and now I'm going to go down 3. So it's down here at negative 2. And that's what my new graph looks like. So it's shifted it up, and it's stretched it. Phew.
Okay, that could.
That cooks.
So the unit circle is just a
Okay,
parent
chef.
function?
Say it again.
The unit circle is just a parent function?
No, but the parent function of sine relates to it. The parent function of cosine
Okay.
relates to it. By the way, I'm ready to teach you that diagram if you're interested.
Yes.
If you come to tutoring someday, we'll go over it. It's going to take a little while. Because I have a feeling you probably don't remember corresponding parts of congruent triangles are congruent,
I don't either.
and similar triangles. So we got to go back and review that.
I mean,
We'll
I
review
had
that.
to look at symmetry triangles for the ACT, so.
So if we review that, then that
Mhm.
diagram is going to be very simple. Okay, we good so far?
Yes.
Okay, give me a 1 through 5. Where are you at?
5.
So you ready to teach somebody else how to do this?
Yeah.
Outstanding, then you can do your own.
Yes.
Okay, here you go. Try this one on your own.
Or actually, can we go back to the?
Nope.
One? Okay.
You already ruined it. You already said you're ready.
I said 4.
Here we go. F of x equals negative 4 sine of x plus 2. Negative 4 sine of x plus 2.
Why would you do this time?
Now, I'm going to go ahead and sketch out the parent function and stuff. I'm not going to give you the answer, so don't be yelling at me like, don't do it yet. I'm not going to.
Do we have to do the parent function?
You do not. I'm just doing it so we can see it. Okay? Besides, this will give me a little bit of time to try and make it a little better. And part of the reason I do that, just so you know, is every time I sketch this up here, I'm sketching different widths and stuff. So I want you to always go back to what does the parent function look like? So this one's gonna look how compared to that. So that's the reason I do it. I'm not gonna ask you to do that on the test or anything. So there's the parent.
I've never liked this paper more. I used to use so much because like the little squares get in the way of my writing, but now it's perfect. I like it so much.
Kevin, you got it done? Yes? Can you pass by the class? Can you pass them by? Your way? That's what everybody says. Goodness, it's-
It's really embarrassing if I messed up.
Okay, thank you. I will get this graded today and posted.
Thank you.
Yep. And so you can ignore your posted grade because I'll repost it. So.
Well, can I still do like the SMS?
Uh-huh. Yeah, remember, quarter grade is just like a picture. They're not transcripted. So it just keeps going, so.
Thank you.
Yes?
Do you ever give us our test paper little things? For
Test.
the test we took? Do you ever give us a test back so we could see what we missed?
Did everyone take it?
No, you didn't give it to us.
I think I saw someone who was taking it.
I want inside a turkey sandwich.
I'm not eating.
Okay. Are we done?
What?
We good? We ready?
Let's.
Okay, let's keep going. Where's the new midline? Positive 2. So here's the new midline right here. Okay? So I'm going to start right here at 0, 2. Okay? Where am I going to be at when I get to pi over 2?
Negative 2.
-2.
Because I go down in a -4. So I go down to here. And then at pi I go back to 0.
2.
At 3 pi over 2, where do I go?
6.
Yeah.
Up at 6. And then at 2 pi, I'm back at 0 or
Wait.
2, the midline.
Okay, I was gonna say you said 0, and I was like, what do you mean 0? It's
Back
2
to the mid. When I say 0, I mean the midline, but it's actually at 2. Yep.
Okay.
So then we're having a function that looks something. Ooh, I missed. Dang it. Phew. Not at all perfect. Not even close on this one. Okay, but that's what it would look like.
You know, if you like drew it well, it kind of looks like the start of a blue whale. It's got the head, and then it has like the tail sticking up at the.
You
end.
just need to stop.
Okay.
Okay?
Okay.
All right, so one more time. Give me a 1, 2, 3, 4, 5 on where you at on just graphing the midline and the amplitude. Okay.
Can we go back
Okay.
to the original problem?
Okay. To what original problem?
The f of x equals a in brackets sine m
The general function?
sine b in parentheses x. Yes, that.
Yeah.
Can we go back to that?
What do you want to know about it?
I want to understand how to do it. Like, do you do sine b times x times negative c?
Okay,
Right.
so I'm going to answer this question one more time because I answered this to Kevin. We're going to teach the A, B, and the D today.
Mm-hmm.
I'm going to deal with the X minus C next week.
Oh.
The B I'm going to teach you right now,
Mm-hmm.
but it gets a little confusing. Allison wants a Jolly Rancher, so please bring her a Jolly Rancher.
Is that v? I mean, is that the vertical?
Okay, so,
Because you said that we're gonna do the vertical next time as well. So is
So-
that the same thing?
here we go. The B.
Can I get some water
The
now?
B actually stands for the period. And what that means is the period is how long it takes to complete a cycle. And a cycle we know is 0 to maximum, to 0 to minimum, to 0. To go from the starting point all the way up, back to 0, all the way down, back to 0. How long does it take to do that complete cycle? That's a period. Okay?
Yes.
So there's a formula for it. It's not a complicated formula. Okay?
Okay.
So what I'm going to do is, I'm going to simply, the formula is period is going to be equal to, in the parent function, how long is a period?
1.
No?
Pi.
Oh, pi.
2 pi.
Oh,
I'll go from 0 to 2 pi. Right?
Is that 0 or 2?
What?
The 2 max.
0 to max to 0 to min to 0.
Oh.
It's the same thing we've been doing,
0 to max
all those
to-
5 points. Okay. 0 to maximum to 0 to minimum to 0. That pattern. Make sense?
Uh-huh.
That's a complete cycle. That's a period. That's going to change. Okay? So we know in the parent function, it takes 2 pi to get there. So if I take that entire cycle and I divide it by whatever my number b is, that's going to be the complete cycle. So there's my formula, 2 pi divided by b.
And that's for everything, right?
That's just for the period.
Just for this, just for what we're doing right now, or does it ever change the 2 pi?
No, 2 pi always stays the same for all of sine and cosines. And we're not going to get to secant and cosecants, but it does say the same for secants and cosecants.
Okay.
Okay.
Why would we get to cosecants and secants?
Do you really want to? I mean, we've only touched the tip of the iceberg. You want to go all the way to the bottom of the water?
Oh gosh, yes.
Okay, we'll get there eventually, maybe in college. But right now, we're just going to do sine and cosine. So it's always going to be 2 pi over b. Okay? So let's give an example. And I'm going to go back to the basics. We're not going to change the midline. We're not going to change the amplitude. All we're going to do is change the period. Okay? So we're going to give you f of x is going to be equal to, let's go with the sine. And we used one yesterday that was really, the kids really liked it. The sine of, and we're just going to give you 3x. There's nothing being added or subtracted, it's just the sine of 3x. So we identify b as being 3, okay? Now I taught it 2 ways yesterday, okay? I'm gonna teach you 2 ways. The other class really liked the second way, okay? I don't care which way you do it, but I'm gonna teach you 2 different ways, all right?
Yes.
And the reason, why would I teach you 2 different ways to do the same thing?
Because one is
Find
maybe
which one you
faster.
like.
Yeah, one might be easier in your head than the other. So if one doesn't make sense, just focus on the second one.
Mhm.
The second one doesn't make sense, go back to the first one. Okay? I don't, because I don't care which way you do it. It's just there's more than one way to look at this. Okay, so we have f of x equals sine of 3x. So what is the period?
2 pi divided by 3.
2 pi over 3.
Oh
So-
wait, and that's on the.
That is on the unit circle.
I
Pretty
think
cool.
it's 4 over 6.
It's not. It's 2 pi over 3.
Wait, 2 pi over 3 is the
So-
thing.
So they're not always going to be in the unit circle. Just to warn you. Okay? In this case, they are. Now, where's the midline?
0.
Still at the x-axis. What's the amplitude?
0.
3. Wait.
Or
1.
1.
The amplitude's still 1. Okay, there's a 1 in front of that sign. Okay, so let's go ahead and graph it. So we're going to have, and once again, just for your information, I am going to draw the parent graph just because I can. I hope that's okay with you.
No,
It's not okay with you?
no, it's okay. I'm sorry.
Okay, you're welcome to leave or something. Let's make this smaller. Okay, so then I want to move this up so I have more room. Move this up. I'm still getting used to the board. Okay, so let's go to, okay, we got blue. So let's sketch my thing here. I'm trying to make this a little bigger this time, so we'll go 2 pi. So halfway is pi, halfway is 3 pi. You should be experts at sketching this out by the time this unit is over. You should be experts at sketching that. You're probably already experts. Okay, so I know the parent function, we're gonna do it in yellow, kind of our theme today. 0, 1, 0, -1, 0. And I've got my 0 to the maximum, to the 0 to the minimum, and back to the 0. Now, this time, it's gonna do this entire cycle. It's gonna go from 0 to the max, 0 to the min, back to 0, by the time it hits 2 pi over 3. In other words, in 2 pi, it's gonna do this cycle 3 times, okay? That's what this here tells us. It's gonna do it 3 times. So that means my length is gonna be 2 pi over 3, okay? So where is, on my timeline, or on my x-axis, where is 2 pi over 3?
Between pi over 2 and pi.
It's gonna be somewhere about right here. 2 pi over 3. It's gonna be in the second quadrant, right?
Yes.
Okay. So what's going to happen is, in fact, let me do this in a different color. I can't change that, but we'll figure it out. What color do you want?
Right.
Orange, good call. So this is going to be 2 pi over 3. So what's going to happen at 2 pi over 3? It's going to start at 0. It's going to go to its min, 0, its max, and it's going to come back and land at 2 pi over 3. Okay? It's going to start here, it's going to go up to its max, come down to 0, hit its minimum, come back to 2 pi over 3. That whole cycle is going to happen in that range. Okay?
So that's what happens when you change the period?
Yes, it's now compressed. It's going to do this cycle, but it's going to do it 3 times between 0 and 2 pi. So it's going to do an entire cycle in that realm. I'm not done yet. I got a lot to get through, but I'll take your question. Just don't ask me what's coming next.
That's not what I was gonna ask.
What are you going to ask?
So basically, it'll look the same as a parent function. No matter what the period is, it'll always be those same things, just smaller.
It'll hit them quicker or whatever. The slope is going to change, whatever, however you want to refer to it. Now, where else is it going to hit its 0? Think about this. It hits 0 here and here. Where else does it hit its 0? The what?
Point of the.
The midpoint of 0 and 2 pi over 3. So right in the middle. So what is the midpoint between 0 and 2 pi over 3?
1 over 1 over 6. 1.
What'd you say?
Pi over 3.
Pi over 3. I mean, it's 0 to 2. So how did we get that? Well, if we take 2 pi over 3, and I have to cut it in half, right?
Yes.
I have to divide it in half. I'm dividing it into 2 equal parts.
Yes.
We good with that?
Yes.
So I'm going to multiply by 1/2. Okay?
Yes.
So I get 2 pi times 1. 3 times 2 is 6. And that reduces to
1 over 3.
pi over 3. So that's where it's also going to hit the 0 at. Okay? Pi over 3.
Wait, then how is correlate to the unit circle at all?
Not going to answer that question. You'll see it as we go. Okay? Now, where are we at? Okay, now, so I've got the zeros. I've got the 3 zeros, right?
Yes.
So what points am I missing?
The
The first
min
one.
and the max?
The minimum and the maximum.
Yes.
I'm missing the min and max. So between 0 and pi over 3, where is the maximum going to occur?
1 over 4.
Going to go to 1.
It's going to happen right in between them, right?
Yes.
Yeah.
Exactly between them. So I'm going to take pi over 3, and I'm going to split it into 2 equal parts. I'm going to divide it in half. So multiply by 1/2. So what is pi over 3 times 1/2?
1, 6, pi over 6.
Pi over 6. So that means that pi over 6, it's going to have a value of what?
1.
1. And that's the first part of my curve. I found out where it's going to hit the maximum at, right at pi over 6. Yes?
So to find the midpoint, where it hits the midpoint, you just multiply the period times 1/2.
Correct.
And it'll, because the half of it, and okay, so that's how you find the midline. And then to find where it reaches the maximum, you multiply that times 1/2.
Correct.
Okay.
Correct. Now this next one's going to be a little confusing, and this next part is why the other class likes the first, or the second method. Okay, so when I teach you the second way of doing it, you might like it a little better, but we'll get to it in a second, yes.
I'm kind of confused as to why we decided to do times 1/2.
Because you're cutting them in half. Because think about this, 0 to 2 pi, it hits the other 0 halfway point. It hits the maximum halfway between them. So you just always multiply by a half. Because you're splitting up into 4 equal parts.
But the period only is 3, so
I'm taking that distance from 0 to 2 pi over 3, and I'm breaking it into 4 equal parts. So if I'm going from 4 equal parts, I cut it in half, and I cut those in half, and now I have 4 equal parts.
why are you putting it into 4 equal parts if it's...
Because that's what the sine graph does. The sine graph has 4 equal parts. The sine graph has 4 equal parts. I'm dividing them up into those 4 equal parts.
So what does the 3 have to do with anything?
So what?
What does the 3 have to do with anything? Because I thought you said that it would do it like 3 times within...
The 3 tells me how I got this number right here. It tells me how long it is.
That's kind of tutoring.
So,
I think you're making this way more difficult than what it is. You're trying to think, and you're just making it way more difficult. Kind of back up a little bit and think about what the graph actually is doing.
So
Okay. I'll come back to it. Yes?
so it seems, as it kind of looks like pi over 2 is the midpoint between that.
How am I going to find where the midpoint is between pi over 3 and 2 pi over 3? How would I mathematically calculate it? Yes?
Add 1/2 to pi over 3.
Not adding 1/2.
Dividing, I guess. Or
subtracting
Dividing.
Okay, stay with me on this one, okay?
Yes.
All right, this is gonna get a little confusing. Hopefully you like method 2 a little better,
Okay.
okay? So the way we would get it is, think about, let's go back to the full length. The whole period is 2 pi over 3, right?
Yeah.
Okay? This right here is 1/4 of it, correct?
Yes.
This right here is 1/2
1/2.
of it. What is this point here?
3/4.
3/4 of it.
Okay.
So you have
Okay.
to multiply times 3 over 4.
So if I multiply by 3 over 4. And of course you would get 6 pi over 12, and we find out it is exactly at pi over 2.
Okay. That makes sense.
But that's how you find it, by multiplying the whole length by 3/4.
Okay.
Okay?
That makes
That's kind of where I lost the other class, and that's fine. They figured it out, but they like the second method better. Okay? And before I take a lot of questions, let me introduce you to the fourth method, or the second method, sorry. Okay?
Wait, are we done yet?
That's the way the graph looks, yeah. Okay. So let me introduce you to the other method of doing it. Either one works for me. Okay? All right. So I'm going to erase this part here. And once again, the other class really liked the second method. Well, some of them anyway. Okay. Let's go to a different color. What color do you want?
Pink.
I don't like red. Let's go with pink. I just think red's too dark. No offense. Okay, so what is the full length? We have the full length is 2 pi over 3, right?
Right.
The full length is 2 pi over 3. How many sections am I dividing it up into?
4.
Dividing into 4 equal parts, right?
Mm-hmm.
Because that's what the sine curve does. It goes into 4 equal parts.
Oh my
So
gosh.
let's take this and let's multiply by 1/4, because that's the same as dividing by 4, right?
Yeah.
So 4 equal parts. Let's multiply by 1/4. And what do you get? 2 pi
Over
12, which is
1/6.
pi over 6, right?
Yes.
Now follow me, pay attention. That's 1/4 of 2 pi over 3.
Yeah.
Then multiply by 2.
1/6, 2/6 pi,
3/6.
3 pi over 6, 4 pi over 6. I'll write them down here. 1 pi over 6, 2 pi over 6, which reduces to pi over 3, 3 pi over 6, which reduces to 1/2, 4 pi over 6,
Gosh.
which reduces to 2/3. So if you can figure and divide by 1, or multiply by 1/4, you figure out what is the length of each section.
That's
Is
way
that...
Then just add them together.
Wait, hold on. Is that option 2?
That's option 2.
Whoa. Okay, never mind. You just said that it would be easier for some people.
I like the first method, because I can do the halves in my mind really
Because you
quick. Some people like this one better.
Wait.
That's crazy.
Wait, but wait, okay, so, so this is 1 period, this is 2 periods, this is 3. So is that what the 3 does? So like, if there was a 4 on there, would we,
So if we keep going, if we said 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, which would be here, here.
The-
I'm trying to do this in my head. Here, here. Somewhere there, yes, it would go something like that, and then it would do it one more time. I'm not getting it quite right, but that's what it would do. It would do
So
up and down,
that's-
up and down, up and down.
So it was like
3
3
times.
I was making it 2.
So we're just trying to figure out, because all I'm gonna ask you in class is, and this is important,
Yes.
I'm only gonna ask you to graph 1 period. Okay? That's all I'm gonna ask you. I'm gonna ask you to graph this 1 period. Okay? So that's how we would calculate where it belongs. Yes?
B was 1/3, would it be 3 times bigger than the 1 period?
It would be, because now it's going to do 1 period in 3 times as long, so in 6 pi. So it's gonna be really, really big. Yep. Yep. As B gets smaller, it gets stretched out, gets flatter. As B gets bigger, it gets more compressed. Yes?
So I understand that like 1 period is the cycle. Like, how do you know how many times you're supposed to do the cycle?
How many times you're supposed to do this? What do you mean?
The cycle, like you're saying, going 3 times on there, but like the period, we're just finding the one. So why would we need to graph graph the cycle 3 times through?
You won't, but that's what it means it's doing. You would only have to graph the first one,
Okay.
but because it's a 3, it's graphing, it's going through the cycle 3 times. Look
Okay,
at
so
2
the
pi.
3 in front determines that.
Which is why you divide by 2 pi divided by 3, because you're doing it 3 times. Yep. Yeah.
For this method, what if you had like a different number besides 2 pi over 3? How do you know to multiply it?
Well, you'd always multiply by 4, because you're always dividing them into 4 equal parts. But this one's a nice example because it's all on the unit circle. Because we know what pi over 6 and 2 pi over 6 and pi over 2, some of them aren't on the unit circle. Okay? Still gonna follow the same rules. You still plot min, max, zeros, everything's the same. It's just, this one's kind of an easier number, we're still working those numbers. They will get a little different, okay? Yes?
Like, would you need to use, like, what was it called? Like, when you're going around in a circle and you find, like, the co-terminal stuff, if it's not harder than getting circle?
So, I hate to get into this one, because this gets a little confusing. But like coterminal would be here and here, they're at the same point. They are coterminal. So then every 2 pi over 3, 4 pi over 3, so forth, those are all coterminal. Not worried about that because we're just doing one period, so I'm not gonna worry about any of those. All right, are you ready to try a challenge problem? The challenge problem meaning I'm gonna give you a change of period, but I'm also gonna give you a change of midline and a change of amplitude. Vincent, think you can do all of this together?
Do we have to do this?
Or you wanna try one more with just a period change?
Just one more of the period change.
One more with the period change? All right, one more with the period change, and we'll put it all together. For this in your notes, example, f of x equals sine, and this time we'll do another fairly easy one, we'll do 4x. Another one that's pretty much on the unit circle, stays with all those same values. Once again, I'm gonna go ahead and just sketch the parent graph, you don't have to do that, but I want you to see it for comparison. Okay? Now that is a very pretty sign.
For sure.
Let's just keep that.
Blaze?
Let's just keep that one forever. I'm gonna take a picture of that.
Okay, so we be over.
Okay. I don't like it there.
2 pi over b. So 2 pi divided by 4.
Don't talk all.
Oh, yes, we are.
You're giving answers to everybody
My
else.
bad.
No, continue talking, please. For the family. Do you hear this?
For the family. Okay. That was perfect timing.
I thought someone like.
You okay?
He's scared. That was a
I
jump
thought
scare.
someone's family member.
You don't understand.
No.
What?
I went to the door and I was going, oh, she got to see. And right when I took my head out, she stuck her head around me.
No, because I knocked on the door 3 times.
That
And
was
I'm like,
perfect
wow, nobody's coming. And I was just staring at the door. So I was like, let me see if anybody's coming. And like, maybe I'll wave at them. And I walk over there and then I just see Mr. Phillips smiling at me. So, so creepily. And it was terrible.
Just call me creepy.
Yes. That was
Just call me creepy.
That's the scariest thing I've ever experienced.
Oh, call it this way, what? Call it
It's
Wait,
just
what
not
are
your day,
you
Mr.
doing?
Phillips.
It's Friday, okay.
I don't even know, to be honest. I can't help you.
Oh, today is Friday. So, are we just graphing this?
Yes.
Okay.
Vincent decided he wanted one more dealing with just the period change, so I gave you another one with just a period change.
Cool.
And then before we leave today, I want to do one with all 3 changes. Yes.
I do it without like drawing the parent function, I can just change the values of the,
I don't want you doing that.
um,
Part of the reason is because when I give you an exam, I will give you, probably not the graph, but I will give you the scale. So then you're gonna have to learn to find it on that scale. You can't, because yeah, technically, I could just change this on here. But I don't want you to do that, because I don't want you to get in that habit.
Okay, I'm confused as to how I should proceed from here. So does it, would it follow the same rules as like this going up, this going down?
Well, what changes that rule?
The negative one, the whatever the frick. You know what I mean.
I
No, you
don't.
don't. But
I mean, I have this pattern. I start at 0, I go to the maximum, I go to 0, I go to the minimum, and I go back to the 0. What changes that? The amplitude.
Yeah.
So that would have to be a negative for it to go down first. Is there an amplitude change? No, so it's gonna go 0, max, 0, min, 0.
Okay.
Every time unless that amplitude changes. My midline is gonna be 0, right? What's gonna change it?
The B.
If something is, no, not the B. Changing the midline,
Oh, D.
it's gonna be this number out here, like +2 or plus or minus 5. That'll change it. There's nothing here. Yes.
So, because the period is 2 pi over 4, can you just put that the period is 1/2?
So, the period, since you just gave the answer to everyone, sure.
Okay.
The period is gonna equal 2 pi over b, 2 pi over 4, which is pi over 2. Now, what does that mean? We found a number. What does that mean? Yes.
It's in the first quadrant.
Okay, so what's in the first quadrant?
The period is the first
The
quadrant.
cycle ends at pi over 2?
The entire cycle will end by pi over 2. And this is gonna go from 0 to the max, to 0 to the minimum, back to 0, between 0 and pi over 2.
Yes.
So that's gonna be its other 0.
Also, this is easy then.
See,
It's
to me,
just like
that's why.
1.
It's easier to do method 1, but it doesn't matter.
R.
Can I use that shit?
Yes, good thing. Oh, man, we were 4 minutes before 10:10.
wait, did I do it? Did I cook? Let me see.
Thank you, Mr. Phillips.
Absolutely.
Wait, maybe not, because...
Wait, Mr. Phillips, can you check to see if I cooked right now?
You know what? In just a minute, I'm gonna put it on the board for everyone to see. You
Is it
can
okay?
check it.
Is it
Yes.
okay if I don't label it? Because I think I might
Shut the heck
get
up.
it.
Oh my gosh, I don't even have Vaseline.
What?
It's okay if I don't like
Alright,
really
Vaseline.
label it or like
It's
maybe, like,
a-
label
No,
it on
I-
the
so
different graph.
You have to
Get me
label it
out
on the
on
axis.
Vaseline.
I have to see
Every one
it.
of you
I
guys
have to
got
see it
on
up
me
here.
about my left
It's
finger.
not
Hey,
because-
hey, question was being asked while you guys are talking. He said, talking about the labels, it has to be labeled on here. I have to see it.
Mhm.
You can't just mark points and just sketch a graph. I have to see the
But
points.
can I put it like on like I made a separate graph to kind of like basically just.
Yes. Yes, that's fine, just don't get in the habit of doing that, because honestly, I could just take this and change that's what River and I were talking about, you can just change these signs here. But I want you to get in the habit of seeing it on the same size scale, because when I give it to you on a test, I'm gonna give you this graph already drawn, and then you're gonna have to plot the points in the right spot. Yes?
I'm confused because, wait, I'm not confused. I lied. I answered the question in my head as I was asking it. Thank
So
you.
once again, that whole conversation could have been.
Mr. Phillips, do you literally hate us?
Sometimes thinking out loud, like actually, like, or speaking out loud, like thinking out loud,
See if
yeah,
we
it
can-
helps you
see
to
if we
like
can
process your
See if you
thoughts.
can scare. How many times are you gonna ask me? How many times are you gonna ask me if I hate you? And those of you watching the recording, I love them so much.
Ah!
He's lying.
And recording.
Oh, you are? Oh!
He's lying.
Do you help finishing it, or you already
No,
finished?
already finished.
Did you scare
Take
him?
it.
Was it scary?
Oh, does Scholar turn his name?
Scholar?
It's between Scholar and I. I'm not allowed to.
Scholar still attending school?
What?
I didn't know she had a class.
She hasn't graduated yet.
That's
Well-
Blaze. That is the most insane Blaze I've
Okay,
ever
so we're
seen.
not working, so we're done. Here we go. So if you want to do method 1, that's fine. If you want to do method 2, that's fine. All I know is if I do method 2, I'm going to take pi over 2 and multiply by what?
1/4.
1/4. I'm going to break up into 4 equal parts. So times 1/4. Now I'm going to find out that each portion, or each section, has a distance of 1/8. Well, if I take
Yes.
pi over 2 and cut it in half, that's going to be pi over 4. Or 2 pi over 8. This one's going to be pi over 8. And this one's going to be 3 pi over 8. So then I know it goes from 0 to 1, back to 0, all the way down to -1, and back to 0. And we see it's very narrow.
I did it.
And then it's going to do that again. And it's going to do it again. Whoops, hang on. It's going to do that again. And it's going to do it again. 4 times inside between 0 and 2 pi.
Wait, what if it's 5 on the under?
What if it's what?
5 on the, like, under, like it's not.
Split evenly.
Oh, you mean like if this is a 5?
Yeah.
Ugh, then you got your work cut out for you. Good luck. And we're going to get to this.
When?
So
Today?
Like,
we can do them today if you
Oh,
want. I
that's-
was going to wait till later.
That's okay.
Okay.
Bro.
Now, let's take this little thing here and let's give you, Vincent, does that make sense? You sure?
Relatively, yeah.
Relatively.
Yeah.
It's like on a scale of 1 to 5, maybe a 2, 3,
Yeah, 3.
3. Okay. So I want you to try one more practice then. We're going to do the same thing, only we're going to adjust the midline and the amplitude. So my suggestion is, are you paying attention? My suggestion is find these points first, and then you know what midline to put it at, and then how far above and below to go. Okay, so my suggestion is find the period first. So try this one. F of x equals, we'll go back to school colors. F of x equals, let's go with 2 times the sine of, should I make it really kind of confusing? No, we'll just make it kind of simple. 2x plus, no, we're going to go minus this time. Minus 1. That's going to be the sine of 2x. So 2 times the sine of I'll get this one. You keep working. 2 times the sine of 2x minus 1. Give it a try. Welcome back. Okay, I'm not going to sketch the answer yet, so relax. We're just going to draw the parent function again.